Okay, let's start chapter 12. That is about circles, but the properties, a lot of properties that we have in this chapter related with the circles. The first lesson that we will have is the tangent line. Um, we already studied about tangent as in the trigonometry, that is about the opposite of the adjacent. But there is property about tangent in circles that are different. The notation is different. For example, here a tangent of a circle is a line or plane. The circle intersect in exactly one point. Okay, I mean the intersection is only in this is only point B. There is no more than this one. Now, this intersection has a particular the first theorem that says if a line is a tangent to a circle, then the line is perpendicular to the radius at the point of tangency. I mean, in this point P that are intercept, the radius made a 90-degree with the tangent. Let's see an example about this. In this relation that we have. Example, the first one is the line ML, this line, and MN are tangents. That means this angle that is in this place is 90-degree and this one is 90-degree. What is the value of x in this equation? Now, remember the addition of quadrilateral is 360. That means we may do 117 plus 90 plus 90 plus x is equal to 360, that is here. There is another way to solve this example, that is, says if we make a line here from the center to this part, the half of 117 plus 90 plus the half of x will be equal to 180 because it's a triangle. But there it is the solution here. Now there is example that I will solve in another video, but here we have example number one. It's easy to understand that because said that ED is a tangent, that means this angle is 90 degrees. But in another video will be the solution for this. Now, let's go for the next. In the same page, we are using the same theorem that said this is 90 degrees, because that we may use a Pythagorean theorem here. And here we have it, the 12, this is the hypotenuse, that is x plus 8 to a second power, all of this to a second power, so it is the distance, plus 12 to a second power, this leg, plus x to a second power, this leg. Then you may see how we solve it here. I will solve this exercise in other video with basically the same structure that is here. Now, there is example here that says identify a tangent using the inverse of the Pythagorean theorem. That means if we make a substitution that 7 to the second power plus 24 to the second power, that it is, has to be equal to 25 to the second power. If that is correct, that means this is a 90 degree here, and that means that the line LM is a tangent. That is the way you may solve those exercises, proving that is 90 degree or not, only applying the inverse of the Pythagorean theorem. Now, the last theorem, there are only two as a matter of fact in this, because there is an explanation in the in 12.2 that I think I didn't explain, but it was it was on the bottom here that says 12.2 that says the inverse AB and OP are perpendicular at the point P, then AB is a tangent. That means is the inverse. And the last one was says if this is a tangent, this is a 90 degree. But in this situation, if this is 90 degree with the radius, then this line is a tangent. Is the inverse of the first. Now the second I was trying the third, sorry, not the second one, the third theorem in this lesson is this that says that BA and BC are tangent. That means the intersection with the 90 degree here with the radius is 90 degrees, 90 degrees here. Arctangent to the circle O. Then, because share this point B, BA, the distance BA, is congruent with the distance BC. We read this: two tangent segments to a circle share a common endpoint, that means the endpoint is B, outside of the circle, then the two segments are congruent that we have. Now, let's see this one in this explanation. If we have this the circle, this is the radius, these lines are the radius, are congruent each other, the same circle, and is 90 degrees, that means this line is tangent to this. The line AE and BE has to be congruent. And here we have the distance. I'm not saying that this part is equal. I'm saying that this segment is congruent with this one. The pink one are the same distance. That's what I mean. Now, in the book, we have example. The examples that we have in the book, first we have this. Now, notice according to this theorem that I just explained, the common point with the segment AD and FA is letter A. If those are tangent, I mean because it's inscribed, circle is inside of the triangle. This 10 AD is equal, the distance is equal to AF. That means this is 10, this distance is 10. And the distance from C to E will be the distance from C to F, that is 8. This is 8. And the distance that is from D to B, it will be the same as B to E. That means 15 will be 15 in this part. And then they make only addition in the final perimeter. In this example that I will show in other video will be the same, but in this one we already have the perimeter. We have to find this missing part. Here I will tell you in the next video what exercise you have to do.